The idea of a mental capacity, cognitive limit, or overloading of our brain is often discussed with this magical number 7. Theories of retired immediate memory, short-term memory, or various modern working memory theories all reference a capacity limit, most referencing George Miller's psychological paper from 1956. But in that paper, George shares his doubts multiple times about this magical number 7, saying the generalization is tempting, but not sound in my opinion. When we examine the matter more closely, there seems to be a reasonable suspicion that it is nothing more than a coincidence. And I suspect that it is a pernicious Pythagorean coincidence, which is huge. The number 7, plus or minus 2 as it is often used, could merely be a coincidence. Many teachers, researchers, scientists, and people from the general public talking about this number capacity might not be that significant. But if we look closer, the word information is used in a very specific way. George refers to information as a dimensionless quantity. The world is filled with variability. When we have a large variance, we can be ignorant about what is going to happen. Lots of information can be confusing. But this is if we use information as a quantity. The ecological approach uses information in a completely different way because of the different starting assumptions to perception. Instead of the amount of information discussed, it is the relational quality of information discussed. However, using the old mind as a machine metaphor, George thinks about us as an input-output machine. So our output correlates to the input, the amount of information, variance, we sense. Then the amount of transmitted information, correlation, is information going from input to output. Information in, stimuli, information out, response. Information transmitted is the overlapping circle or the channel between the two. If the response or the behaviour was good, the transmitted information was good. But if the response or behaviour wasn't good, then there was an error somewhere with the transmitted information, a processing problem. Something was lost from the input to the output, the channel from input to output having a capacity limit. But this limit was first explored through bits of information, the amount of information that we need to make a decision between two equally likely alternatives. So a binary decision, yes or no. However, decisions aren't that simple. There are way more factors to consider, which George describes as multi-dimensional judgments, going on to say that we are less accurate when judging more things at once. He wrote, "Everybody knows that there is a finite span of immediate memory, and that for a lot of different kinds of test materials, this span is about 7 items in length. But note, items are different from bits. Bits can help make a judgment, but our immediate memory can hold way more than 7 bits. Absolute judgments are different from the span of our immediate memory. This is where chunks of bits can be used. So 7 bits is different from 7 chunks or items, and each chunk could have different amounts of bits." I just want to emphasize that. Some chunks can be bigger than others, but still count as one. Number 2 is 1 bit and 1 chunk. Number 27 is 2 bits, but 1 chunk. 2710 is 4 bits, but 1 chunk, if seen as a number, but could be 2 if seen as date and month, so 2710. 2710-2001 is 8 bits, but could be 1 chunk, 3 chunks, or something else. It depends how we group the bits together as to how many chunks there are. This process was termed recoding. The person, or as we are talking about perception, the organism is grouping the bits together. The organisms, or as George describes it, observers, are remembering the new name of the bits as a chunk, rather than the granular bit breakdown. You can see in Table 1 binary digits being grouped together into chunks. But this process of grouping binary digits into numbers was hard to learn. So George Miller did what Ebbinghaus did with the forgetting curve and tested it himself. He practiced grouping binary digits into numbers, then repeated the tests to see if he could remember more digits. And it worked. He showed that when we think of information in chunks, the more we can reduce into chunks, the better we are at remembering more bits. So we should try and make more chunks, group things together more. But what's important here, I think anyway, is the way he groups the bits into chunks. The information has a different meaning to him after practicing putting binary digits into numbers. Bits relating to the person, organism, observer in a specific way. A year, 2001, being 4 numbers. If you see a 3-digit number but BC after it, that might also be a year, but only if you've experienced and paid attention to that relationship before. 3 numbers and 2 letters. I feel like Miller, and by extension many of the theories that use this number limit, overlook or underestimate this relationship a little bit. Instead of information being lost in transmission from input to output, could the response or the behaviour be down to the relationship between the organism and the information? A focus on how the bits relate to the observer, which could be described as chunks, instead of quantity of bits. If that is the case, then the number might not be that significant, which changes the research methods, studies, and application of theories in education. Instead of a capacity or limit, the relational qualities of the information is arguably more important. The ecological approach explores these alternative ideas in sports coaching, which is what I shared more about in this video when Mike argued against the ecological approach.